WordPress is pretty popular, right? 33% according to WP Zoom websites is using WordPress, which also means it's a pretty popular place for vulnerabilities, right? So let's start with a question because I know you were all partying hard yesterday. So guys, how many new vulnerabilities were found in 2024? Was it A, almost 8,000, B, almost 11,000, maybe 21,000, or just 6,000? What do you think?
Oh no!
That's true. It's 7,966. And you know what? Every year it's growing. And I know it might sound a bit scary, but that's good news because every time when we discover a new vulnerability, it means we can do something about it. We can inform the vendor. Sometimes they even fix it right away. Sometimes it takes a bit longer. But in general, it's really good news that we'll find it. But still, it's a lot of vulnerability. And like I said, it's constantly growing. You can find more information. We have the reports every year. But the truth is that this is the point when us as humans might start to have problems with handling this. But luckily, we have people like Rashmi who can help us automate everything.
Alrighty, yeah, sure. We can try about automating, but of course, there is always a pros and cons behind automating stuff, and there is a lot of need for human in the loop while we are devising such systems. You must have seen about the Cursor AI, which is an AI assisted code editor we all use. We are aware about that, right? Which has found a vulnerability. It has a vulnerability which is RC, remote code execution, which means a hacker or an attacker, if he or she has the access to your code base or to your system, they can inject malicious code. Isn't it scary? Well, that's just the tip of the iceberg. There are a lot of code vulnerabilities. It not just creates a reputational damage to a system, to an organization, but it also leads to hefty fines by the organizations. If you're ready to pay hefty fines, sure, please go ahead. Don't use PathStack, but still, please try to our PathStack code base, our tools which are already existing in place. Okay. Before we even delve deeper how we can automate such systems, you need to understand certain statistics. And from the latest article, it says that 96 of the vulnerabilities were found in the plugins. Again, one of the core components of the WordPress ecosystem, right? And 96% of them are in the plugins. Well, the severity of it does vary, right? We have low vulnerability, medium, high, so on and so forth. The breakdown over here shows we have XSS, which is on a high demand over there. Wow. We also have broken access control, cross-site, like all of these. You can read more about this on a white paper, which we release yearly. And he's the one also lead author in all of, all these white papers. So give it a shot. You will understand what are the stats, which is going on in the WordPress ecosystem, and what are the ways in which Pasta can help in mitigating some of those vulnerabilities. All right. Now I want to shift the gears because I want to make sure all of us are on the same page. So just the basics, sprinkling the basics of AI, what exactly it is, what is the deep learning, what is machine learning, before we delve deeper into how we can use these AI tools to automate the patch. So AI, it's a broad term, it's a big umbrella, which means we are mimicking the human behavior through a set of rules and set of steps around it. What is machine learning? It's basically you are programming the system so that it learns from the data. You can see over here spam email detection, right? The Gmail has a feature of spam email detection. Basically, it has the regex automation of all of these. It can detect whether the email is a spam versus not. Deep learning is a one step ahead, which is extracting the patterns from the data and then gives you the output, like the handwriting recognition. I have a bad handwriting, and sometimes the computer says that, Rashmi, you should improve your handwriting because it has trained on some of my existing information around. So deep learning is basically extracting the information from the existing data. All right. So now I want to test the waters. I've explained a little bit basics. What is AI, machine learning, deep learning? I want to test the waters. I want you all to take a minute and think. Think which of these faces are the real faces. Which of these faces are the real faces? Oh, come on.
Tim, Tim, don't cheat.
Yeah. No, you can't be hijacking this question. No, I'm just kidding. Sorry. Okay, please raise the hand if you think the face A is the real face of a human. Good. Please raise the hand if you think the face B is the real face. Wow, it's 80% people. See? Okay, what do you think about the face C? Is that a real face? I like the two people raising their hands. I love the participation of the audience here. So, the answer is none of these faces are real. Yes. So these faces are generated using generative AI technologies. I'll explain later. And also, I can make sure this code is open source so you can replicate on your data set. So I think these people exist on the planet Mars, right, Misha?
Probably, yeah.
Yeah. Okay. So this information or the data is generated trained on the existing human faces data set, and it was generating the patterns based upon the existing information. This is an example of generative AI that we use DALI, Midjourney, all these image analysis or image generation tools. What is going behind these scenes? There is a transformer architecture and there are different use cases around it. So the LLM or the generative AI technology, it is used for various purposes. It's used for reasoning, code generation, summarization, vulnerability detection, and so on and so forth. But it generates on the basis of a probability. Like the example here is the garden was full of beautiful butterflies. It could be a flower or it could be, like the people. People are also beautiful. Come on, right? So, anyway, so it generates this response based upon the probability. Our problem, the core of the part of our slides, the presentation that I and my colleague we are going to discuss is how can we automate some of these systems, security workflows within the WordPress ecosystem. So first, we are going to build a multi-agentic framework which automates the detection of the vulnerabilities, generates the patches, and also validates the fixes using AI tools. So it's a multi-agentic framework. Before I even start with how I design, how we both design and discussed about it, first we need to explain certain basics, right? What is a multi-agentic framework? So it could be a single agentic, multi-agentic, could be a supervisor. And this is an example like you have an agent which has certain tools and certain different agents. And every agent has a specialized task to do, right? And those tasks, once they are performed, there is a consensus agent which is going to, get all the information consolidated and gives you the final response. For our use case, the one use case which I showed before was the question was automated detection, generation of the patches, and validation. So we have broken down that problem into three phases. The first is vulnerability detection. So here, what the information we are getting is we are getting the WordPress plugins code base. And then we have to identify vulnerabilities in those plugins. So this is the architecture we defined for the first agent. This agent is going to have a dataset input. Then it is going to pre-process information and it's using a big architecture, which is using DeepSeek R1, or you can use the GPT OSS model as well. And then it gives you certain response. You can see the response like this. This is for one plugin, and that plugin has SQL injection, so on and so forth, vulnerabilities. It gives you exactly which code within that entire WordPress plugin has a vulnerability and why it does have. Right? You can see the explanation, which is human comprehensible and with a certain confidence. So this is how the response of the first agent looks like. Then we have a next agent, which is a patch generation. Now we have identified vulnerability, how we can patch it or how can we fix it, right? So it has designed in this way that you have vulnerable code, which is identified by the first agent. So the input, or you can say the output of the first agent, is taken as an input to the second agent. And that's where the multi-agentic framework lies into the picture, right? And then you are consolidating the output at the end. So in the patch generation, you are again using the DeepSeek model, or you can use the GPT OSS model released by the OpenAI. Before even using that model, you have to context engineer or prompt engineer it so that it takes in what is the existing information. And then it has to use some knowledge base. Okay, what kind of vulnerabilities it could be and how to generate the patch around it, right? That information has to be provided. And therefore, this architecture highlights all of that. And this is what the response you will get. For example, if you have a certain code, right, a vulnerable code, it generates a patch code and then it gives you the confidence. And it also runs some test cases to validate it, like why this particular patch code is there. And you can see a small code snippet here, which is I'm using a model from the Olama. So I'm actually a big fan of using open source models and fine tuning that. So you can use Olama model and you can fine tune on the basis of it. There is a small prompt engineer, the prompt that I've written here that given you are an expert and then you have to fix a vulnerability and certain details around it. The next part is identification of the vulnerability is done, patch generation done. Now let's validate that patch. So this is the architecture of the patch generated. You have certain code components. You're also doing some injection test. Whatever the code being generated by the model, you have to test it, right? You have to use the algorithmic strength, how far or how efficient it is. Then you have to make sure it is also complying with certain patterns around it. And at the end, you will consolidate all the responses into a nice looking report. And this is what the response looks like. That, okay, the model has generated a patch. Now with a certain confidence, it is saying, oh, you know what, the model has not fully patched it. So let's address it. And sometimes it says, okay, now the patch generated is perfect. So you should go ahead with fixing it. Right? Okay, now this is just the glory picture. I can show also the terminal. Okay. So I have already run the code here. You can see there was a vulnerable code on this line that select star from users where username. It's a string concatenation which is happening, which means, it's a SQL injection example, right? A hacker could actually concatenate any possible strings. And then the patch code is like parameterized placeholders. So you have to identify or put the response, which is exactly in the database, right? And then it gives you nice human comprehensible explanation of why this patch code is correct. So this is the response of the patch agent. Okay, now I've explained the glory pictures of using AI models, using LLMs. But there are certain use cases, and one needs to be aware about that. It's not the rosy pictures. LLMs are perfect, but they are also lacking a lot of loopholes within it. First challenge is they hallucinate. Well, okay, now before even I start with the hallucination is, I want you all to take a minute and think. Actually, not a minute. It should be like a couple of seconds, right? Okay, because I'm not from Vietnam, so I'm not sure about what as the Vietnamese language looks like, but I need your help. First question is, what is the capital of Vietnam? Oh, I know the answer. It's Hanoi, right? That much information I have. But if I have to translate, which of them looks like? Is it A? Anyone? Okay, let's take some random guesses. Okay, one has said A. B, you're right? Yep. So, what the model has given? It has given the answer, right? I asked for the translation. So, hallucination is one of the core components, or I would say the response models gives. Why? Because it produces They produce the responses which seems plausible, which means, oh, they are correct, but actually those are fake responses, or the responses which doesn't even make sense. There's another question. I was curious, and we both were trying and twiddling around with LLMs. And this is one of the important questions that we both think maybe let's try with LLMs. So, um, what do you think the response for this would look like? If Alice has n brothers, she also has m sisters. How many sisters does Alice's brother have? Pretty basic question. Just like we both were struggling a bit.
Yeah, I made a mistake. The same as AI.
Okay, the first. Is it the answer should be the first for this question? Okay. Do you think the answer is the B? I'm not looking at you, Tim. All good. Don't worry. Okay. What do you think about the answer? C.
Yeah, they're right.
What about the C? Oh, sorry, the last one. Okay, good. Oh, well. So I'm using Gemma because I don't think it's visible at the end, but this is a Gemma 3 model, right? It was released like a month or 2 months ago. And it gave me the final response as M. Like the Alex has M sisters. It should be Alice plus one, right? See, so this is an example of hallucination. So, well, this is all not a rosy picture of using LLMs. We need to be sure about what is coming up, in terms of the responses. And there is absolutely need for human in the loop while we are using LLMs for generation of certain of the security workflows for our use cases. I think and also we have this context limit, like you can't parse like a lot of information to the models, right? So we need to be aware about whatever the information we are passing to the model should be able to understand. Now over to you.
So I have 20 seconds, so it will be a bit difficult. But I will quickly try. Let's talk very quickly about vulnerability disclosure policies. And yeah, Rashmi did a very interesting talk, but I have to talk about the boring stuff too, because AI is really changing everything quickly. I mean, you can see this vulnerability that was discovered by our AI, no human involved at all. But discovery and fixing is just one part, and we still need some foundations, some procedures. That's why those vulnerability disclosure policies that includes the set of rules, the scope, how you handle vulnerabilities is still so important. And exactly like with hosting, setting an Apache server or Nginx is quite simple, but no one does it apart from hosting companies, right? Because it's sometimes easier to pay for someone to do it for you. That's why there are also managed vulnerability disclosure programs where you can pay or not for someone to help it with you. And well, I have minutes time, so in short, the discovery is just a part of the process. Still, releasing the fix, how you release it. Sometimes you have to hide some things just to make sure that the hackers won't see it right away, especially when it's critical. Sometimes you need a force update from the plugin team. So there is still a lot of work for us, for security researchers, that is needed. Also, the CRA is coming, and you should come to Simon's talk that will happen later, and he will talk about the CRA more, and he will explain what can happen if you don't follow the rules, and VDP is a part of it. And yeah, so let's kind of, in conclusion, remember, we are still needed. Just a part of our work will be done by AI. And with this, let's say thank you so much.